Okay, Assalamualaikum and hi everyone. So today we are going to proceed with the next method in solving the differential equation, which is the linear equations. Okay, so in general, this is the equation that we have in general, which is we are going to have the coefficients of ax, bx is equal to cx. Okay, so when we are saying about the linear equations, the coefficients of this term must be equivalent to 1. So what we are going to do is you have to divide this coefficient through all the terms. Okay, so it becomes 1. Okay, so then the second term becomes bx over ax, and then the third terms becomes cx over ax. Okay, so the idea is you have to make this term, this coefficient is equivalent to 1. Okay, so after that we also can write into this form. Okay, so this is the patterns how when we simplify the bx over ax here equal to px, and then the cx over ax here becomes qx. Okay, so whenever you look into the patterns, the linear equation later on, you will know that any coefficients that belongs to y here is the px, and then this one is qx. After you have make sure that this term is equal to 1. Okay, so the next we calculating the integrating factor. So what is the integrating factor? So this is the equation that you have to remember, which is the mu is equal to the exponent to the integrals of px dx. So what is your px? This is your px. So that is important for you to know, to determine where is the px in order to get the integrating factor. Okay, so then what you can do is that you can write the equations into forms of d over dx mu y equal to mu q. So what is your mu? Integrating factor, and then this is your y, and then this is your q. Okay, so you are going to solve the p in searching the integrating factor, and then the q just copy here to solve the equation. Okay, so then when you differentiate this one, you are going to have the mu y is equal to the integrals of mu q dx. Okay, and then settle, you are going to have the equations of y is equal to what? Okay, so that is the basic idea on how to solve the linear equation. Okay, so for better understandings, let we go through the example. Okay, so in this notes also we are providing you with the detailed explanation, so you can refer to these notes later. Okay, so let's look into the example number 1. Okay, so solve the first ODE differential equations given by this one. We have the dy over dx plus these coefficients and equal to this one. Okay, when you look into this equation, you already know that the first coefficients that belongs to y prime is equal to 1. So you do not have to do the modification. You can just straight away. So you know that this one is px and then x. Okay. After you determine the px and qx, okay, so your px and qx based on the given differential equations. So now you have to find the integrating factor of mu x, which is equal to e to the power of integral px dx. Copy back the values of px. So your px now is equal to 1 plus x over x dx. Okay, you simplify this, it becomes 1 integrate of 1 over x plus 1 dx. Integrate 1 over x become ln x, integrate 1 becomes x, and then you simplify both, cancel the e with the ln, and then you will get x ex. The third step is equation, you have to remember d over dx mu y is equal to the mu q. Okay, so copy back your integrating factor, and then y equal to the mu q. So copy back your q, and then this is your mu. Write back the equation and substitute the particular value for the integrating factor and also q, and then you solve this one. Okay, so now your y is equal to e to the power of x over 2x plus c over x e x. Then you are done. Okay, alright, so next move to the second example. Using the z is equal to y square, convert the following non-linear DE into linear DE. Okay, so this is the given equation, which is you have the x square y dy dx minus xy square equal to 1 come together with the initial conditions of y1 equal to 1. Okay, so solve the linear equations. Okay, for the first step, what you have to do is you have to differentiate the z is equal to y square in order to get the dy over dx, okay? And then you have to replace into the non-linear equation. So this is another method, another way to solve the non-linear dA instead of you are dividing the whole terms with the first coefficient, okay? So the first step is by taking the z is equal to y square, you have to differentiate the z with respect to x. So here you will get the 2y dy over dx. Okay, and then you simplify that to get into, to make it into these terms. Because of, we are going to substitute this in terms of z later on. Okay. Okay, so the second step, what you have to do is change the equation into the general form of linear equation and determine the px and qx. Okay, so basically we are going to just modify the given differential equation and then make it into the linear form and determine the px and qx. But in this question it's quite different because we are going to substitute the we have to consider the z is equal to y square before we can move to the determining the px and qx. Alright, copy back the given equation. So now you already have this form, which is your y dy dx is equal to half dz over dx. Okay, so you substitute back and then now make it in terms of z. So your y square is equal to z. Alright, so simplify this one and divide all the terms with the x square over 2. So then this is your linear equation form since the first coefficient of the first term becomes 1. Okay, so then you know that this is your px and this is your qx. Okay, so you have done in determining the px and qx. Okay, so next proceed with the find integrating factors of mu x. Okay, so your px is equal to negative 2 over x and then integrate this one, you will get negative 2 ln x. Okay, so bring the negative 2 to this and then you will get the e ln x to the power of negative 2. They cancel e with the ln, so you will have 1 over x square as your integrating factor. Okay, so we move in finding the y. Okay, this equation, this formula you have to remember, d over dx mu z is equal to the mu q. So copy back your mu and also the mu q here. So your mu q here becomes this one. Okay, so after that what you have to do, you have to integrate the right side and then you will get the 2x negative 4, integrate this one, it becomes negative 2 over 3x power of negative 3 plus c. Okay, so now you have your z, the equations of z is equal to negative 2 over 3x plus cx square. Okay, so what you have to do, you have to substitute back the z is equal to y square here. Comes y square equal to negative 2 over 3x plus cx square. Since the question gives you the initial conditions of y1 equal to 1, which is your x is equal to 1 and then your y is equal to 1. So what you have to do, substitute back to the equation and then you will find you will get your values of c, which is 5 over 3. So substitute and then this will become your final answer and then you're done. You just need the 3 steps. Okay, 1, 2 and 3. Okay, so you have to remember this one as well. Okay, simple. Okay, it's quite okay, this is the quite a special example here. Okay, because you have to use the z is equal to y square in order to solve the given differential equation here. Okay, so how to do that? Okay, the first step is we have to differentiate the z is equal to y square in order to get the dy over dx and replace into the non-linear equations. Okay, this is another method. Instead of you are dividing the coefficients throughout the equation, so you have to differentiate the z is equal to y square, because of we are going to find the dy over dx. Okay, from this we are going to find the dy over dx. Okay, so how? Given that we have the z is equal to y square, so differentiate to the first order, differentiate with respect to x, we are going to have the 2y dy over dx. Okay, that is the difference when you are differentiating with respect to x compare you are solving for the differential. Okay, so the differentiations and differential is different, so try to look back to the definitions of both. All right, so when you differentiate, we are going to consider the second variable in that equation, which is dy over dx. Okay, since we are differentiate with respect to x, so the remaining, since we are differentiating, we need to consider the dy over dx. Okay, so then all right, so next we are going to simplify this part. Then your y dy over dx is equal to half dz over dx. Why dy over dx? Okay, because this is the key. Okay, we are going to substitute it back to the y dy dx. Okay, so change the next steps. Change the equation into general forms of linear equation and determine the px and qx. Okay, so x square y dy over dx minus xy square equal to 1. This is the given equation. Okay, so the next step is we have to change the equation into general forms of linear equation and determine the px and qx. Okay, so the keywords here is, before we determine the px and qx, we need to modify, we have to make the equation until we get the in the forms of linear equation. Okay, so what we have to do, we know that the y dy dx here is equivalent to this part, right? So you just substitute it back, and then you have to divide the equation with x square. Okay, sorry. Okay, after you substitute okay, so after you substitute the dy over dx, okay, you have to divide all the equations with the x square over 2. So you are going to have dz over dx minus with the x, so you have to divide with the x square over 2 throughout the equation. So the first term becomes dz over dx minus with cancel 2 over x z equal to 2 over x square. Okay, so divide it by using the x square over 2. Okay, so now this is your linear equation. Okay, as long as you have modified the first terms of y prime is equal to 1, this becomes your second terms, and this is this will become your px, and this is your qx. So you have determined the p and also the q here. Okay, settle. Okay, so the next step, we have to find the integrating factors of mu x. Okay, how? Just copy the equations of px here. Okay, differentiate 2 over x becomes 2 ln x, and then when you simplify, you will cancel this one, become ln x negative 2, is it? So your solution becomes 1 over x. This is the final this is the solutions for your mu x. Okay, so what's next? Finding y. So you have to find y. How? By writing this equation, d over dx mu z is equal to mu q. Copy back your mu here, and then copy back your q here. Alright, so after you solve, what is your q? 2 over x square. Okay, okay, so solve this part. Okay, solve this equation after you substitute the equations of mu x here. Okay, and then also the q. So when you solve this part, you are going to have the equations of z is equal to negative 2 over 3x plus cx squared. Okay, so you have to remember that just now your z is equal to y squares. Substitute it back, convert back, because we are going to find the y, not the z. The z is just only we use it in the beginning of the solution just now. No need to get the final answer. The final answer must be in the y is equal to what? Okay, in terms of y is equal to x. Okay, that is the key. So this is your final solution. Y squared is equal to negative 2 over 3x plus cx squared. Okay, we cannot stop until that because the question gives you the initial condition. So we have the y1 equal to 1, which is your x is equal to 1, and then your y is equal to 1. So what you have to do, substitute in your equation here, substitute the value in the equation to find the values of c, constant c. So after you substitute the value, you will get the c is equal to 5 over 3, and then copy it back to get the final solution. Y squared equal to negative 2 over 3x plus 5x squared over 3. Okay, next one. We move to the example number 3. Find the particular solutions of differential equation. Okay, this is the equation. dy over dx plus y tan x equal to cos x. Okay, which satisfy the conditions of y equal to 1 and x equal to 0. So it's already give you the initial condition for the equations. Okay, so straightforward. Since your coefficients of the y prime is 1, so you can straightforward identify your px and qx, which is your px is equal to the tan x, and then your qx is equal to the cos x. Okay, done for the first step. Finding the integrating factor. Okay. So mu is equal to this equation. You just have to substitute the values of px here, which is integrate tan x equal to negative ln cos x. Okay, when you simplify this one, bring the negative becomes power, so cancel the ln becomes cos x to the power of negative 1. Goes to the previous example, we just substitute the values of integrating factors of mu and also the q1 here. Okay, secant xy, so integrate 1 becomes x plus c, so your y is equal to x plus c over secant x. Okay, so this is the solutions for the y. Okay, so what's next? Since it gives you the initial conditions of y equal to 1 when x is equal to 0, so substitute into this equation, you are going to find your c. Okay, so now your final solution is y is equal to x plus 1 over secant x. Okay, and then you have done. I think this example is quite straightforward. Okay, this is a basic one. So maybe after the third example given here, you already get the idea on how to work with the linear equation. Let's proceed with the example number 4. Okay, given that this is the differential equation, A, show that the integrating factor is x minus 1 ex. Okay, so how to solve that? Okay, so we are finding the mu, so actually you have to just straightforward to solve the given DE. Okay, so what you have to do is to make sure that this becomes 1, so divide all the terms with the x minus 1. So now your px is equal to x over x minus 1, and then your qx is equal to x over x minus 1 as well. Okay, so after identify the p and also q, you can finding the integrating factor here. After you substitute the px, you will get your x over x minus. Okay, in finding the integrating factors of mu, so you have to integrate the px. Now your px is equal to x minus 1. So to integrate x over x minus 1, what we have to do is long division. Okay, so in long division, what you have to do, x divided with x minus 1, 1x minus 1, you become negative 1. So then it becomes into this form. So then you can integrate integrate 1 becomes x, integrate 1 over x minus 1 becomes ln x minus 1. X minus 1 cancel, x minus 1, and then this is the final answer for mu. So you have proven that your integrating factor is equal to x minus 1 ex. Okay, we settle. We have done solving the for of the DE with the conditions of y equal to 0 and x equal to 2. Okay, so solve. Next, we proceed in solving the solution. Okay, so remember this one, d over dx mu y equal to mu q. So this is you have to remember in order to solve the equation. If not, you won't able to solve this part. Okay, so copy back your mu and then your mu here and also the q, then you solve this part. Okay, so whenever you want to solve, okay, integrate this x ex. Seems like we are having the two different classes of function, which is the what? Algebraic and also the exponent. Okay, so what you have to do? Solve it by using the integration by part and then consider the lineage. Okay, so algebraic here, exponent here. So algebraic stand differentiate, exponent is for integrate. Okay, so we used here tabular method in solving the integration by part. Okay, so for the sign, we're starting from the plus, minus, plus, and then copy the equations for algebraic, which is x, and then we differentiate until we get 0. Okay, for the integration part, we have to integrate. Okay, following this one until you get 0. Okay, and then copy. You have to write it back. Okay, following the arrow, x ex plus minus with the e to the power of x and then plus c. Okay, for those who I cannot remember the steps or the concepts of the integration by part, better you have to do your own revision because this is important. Okay, so whenever you start on solving the integration part, you are unable to solve this whole equation. Okay, the whole example. Alright, so better take a look for that topic. Okay, when you solve this one, please bring this to the right side, then your y is equal to this one. Okay, so you have done solving that. Okay, so since your question gives you the conditions of y equal to 0 and x equal to 2, so you have to substitute in order to find the c. So now your c is equal to negative. Now you find your u. So now you already have your c. So substitute back into this equation and then your final equation will be like this. Okay, and then you're done. Okay, the next one, C. Question C. Find the limiting value of y as x is approached to the infinity. You have to put the limit x approach to positive infinity to the both side. And then when you solve this one, you have to simplify this equation. Then the final answer you will have is equal to 1. Okay, so you have done. Okay, settled in solving for the example number 4.